Alright, so let's take a look at this Physics 2020 Trial Self 2. We have this light incident normally on a glass prism as shown. So we have this refractive index of glass which is 1.5. Define the term refractive index in terms of the speed of light. Okay, so 2 marks, right? So first thing first, for definition you just have to memorize by heart. But sometimes you must also see the context. So especially for this case, right, you notice that it's 2 marks. So there's more than meets the eye. So let's write down first. Okay, so the first mark you just say that the refractive index is the speed of light in vacuum. Sorry, is the ratio of speed of light in vacuum to the speed of light in the glass. So that is for the very first mark. Okay, second mark, you just say that, okay, so since we are given the refractive index of 1.5, so you just have to say the speed of light in vacuum is 1.5 times the speed of light in glass. So that is the very first part. Okay, let's take a look at part B. So with this ray of light passing through the prism and leave the prism at point P. So at point P, right, you go into the air. So the angle of incidence of the ray at point P is 30 degrees. So on figure 11.1, draw the normal at P, the angle of incidence at P, and the path of light as it leaves the prism. Okay, so let's draw. Okay, so you draw the normal here. So normal, just make sure it's roughly 90 degrees lah. After that, you draw the angle of incidence. So for this, right, just maybe relax on the assumption that the angle of incidence is always in the less than medium. So I just draw here. So the angle of incidence is roughly 30 degrees. Then after that, the path of light as it leaves the prism, so you just have to bend away from the normal. So that is already 2 marks already. Okay. Alright, so part 2, calculation again. Okay, calculate the angle through which the ray is deviated from the original direction as it leaves the prism, and of course we must show our working. So now we are not required to calculate the angle of refraction, but we must calculate what is the angle that it deviated. Okay, so first thing, let's go back to this thing. Okay, so I want to calculate what is the angle right here first. So I want to calculate this angle. So how do I calculate? So always use n equal to sine I over sine r. So the n is 1.5. Okay, the crucial thing now is which one is the I, which one is the r. So if you are doing calculation, just take note that our 30 degree, we put it here. Then after that, the I, the so-called I, we put here. Okay, because if you put the other way around, you will get the wrong conclusion already. Okay, so let's calculate. So R is put 30 degree. Okay, so 1.5 equal to sine I over sine 30 degree. So next thing is sine I equal to sine 30 is 0.5. So 1.5 times 0.5. So it's roughly 0.75. So of course, angle of incidence, you just inverse the sign. So you should get roughly 48.6 degree. So this angle right here, which is bigger than 30 degree, must be 48.6 degree. But this is just, this is the angle of refraction or angle of incidence is in this case. So the question one, what is the angle that the light deviated? So what does that mean? So for example, right, okay, I draw here. Okay, so for example, if I have a light like that, okay, so imagine that there's no glass prism. If there's no glass prism, I'll just go straight through like this. Okay, now I put back the glass prism. Of course, the next thing is I draw the normal. Then this is the 30 degree. So this 30 degree. Then the next thing is, okay, so this 30 degree, this must also be 30 degree because of opposite angles, right? So next is you draw the light ray that I just redraw just now. Because you put back the glass block, you must draw like this. Bend away. So when you bend away from a normal, right, the angle right here, which we calculated just now, is 48.6. So this is 48.6 degree. So the question actually want us to calculate what is this angle right here. So you just use 48.6 minus away 30 degree. So you should get an answer of 18.6 degree. So that's the answer for part 2. Right. Okay, so let's move on to part C. Okay, part C, we have this light, which is same thing, incident normally on another glass prism. The prism is also made of the same glass. It means that the refractive index is the same. Okay, so now let's look at what they want. So the ray of light is totally internally reflected in the prism. So on figure 11.2, draw the path of light as it passes through and emerges from the prism. Okay, so I just calculate. I just draw. And after that, you can draw a normal right here. Okay, draw a normal, then after that you just, because you undergo total internal reflection right here. So you cannot go into the air, you must undergo total internal reflection and exit the prism here. So that is for part I. Okay, part 2. Explain why the light is totally internally reflected. 2 marks. So 2 marks means we must mention 2 points. Okay, so first thing first, how do we answer this question? So you look at this 45 degree and 45 degree. Compared to this part, 30 degree, this is 90. Of course, this is 60 degree. Okay, so what's the main difference is the refractive index is still the same. Just that maybe the angle is a bit different. So 45, 45, 90, isosceles triangle, right? So, okay, so you just tell them that the angle of incidence right here, you calculate the angle of incidence right here. So which is roughly 90 here, 45 here, right? So this must be 45 degree. So that is the first credit already. Then the next credit, you must tell them what is the critical angle of the prism. So the critical angle of prism, I think we didn't calculate. So okay, since we are given a 1.5, I can calculate for them. Okay, so very first part is the angle of incident in which the light hit the surface of prism is 45 degrees. So that is the very first credit. Okay, second credit, you can say that, okay, so since sin C equal to 1 over n, right? So when my n is 1.5, so the critical angle you should get roughly 41.2. So the critical angle of the glass prism is equal to 41.2 degree. So since your angle of incident is greater than critical angle, hence TIR occurs. So that is how we approach this qualitative question. Alright, so that is it for your try yourself 2.